During the walk-around, you must check several items which are part of the fuel system. These items are not major components, but a check of their condition is very important.
Fuel can be measured manually by the magnetic fuel level indicators, installed as follows. 1. Under the center fuselage, 4. Under each wing inner tank, and 1. Under each wing outer tank. We are looking at a magnetic fuel level indicator under the right wing inner tank. It should be flush with the aircraft surface. Water drain valves are installed as follows. 2. Under the center fuselage, 1. Under each wing inner tank, 1. Under each wing outer tank, and 1. Under each wing surge tank. We are looking at the water drain valve in the right inner tank. You should check that there is no water leaking from the valve. If there is a leak, call maintenance. A surge tank is connected to the outer tank in each wingtip. These small tanks protect the system against overpressure and thermal expansion. You cannot monitor or control surge tanks from the cockpit. The surge tank inlet should be clear of any blockage. The fuel ventilation overpressure disc should be intact. Note: the disc is intact when a white painted cross is in view.
A refuel panel is located on the fuselage side beneath the right wing. You should check that the refuel panel access door is closed. A single refueling point is installed under the right wing. You should check that the refuel coupling door is closed. Note: another refueling point can be installed under the left wing as an option. There is also a shroud drain mast, which drains fuel that could leak from the system. You should check that there is no fuel leaking from the mast. The items related to the fuel system during the walk-around have all been seen.
We will now discuss items related to the fuel system that you will encounter during cockpit preparation. To better illustrate what occurs, we will select the ECAM fuel page for you. With the pumps in the off position, the ECAM shows the pumps cross-line amber.
During cockpit preparation, all white lights in the cockpit must be extinguished. Switch on left tank pump 1 and observe the ECAM indications.
Left tank pump 1 on the ECAM fuel page is in line green, indicating that the pump is running. We have pressed the left tank pump 2 push button switch for you. Left tank pump 2 is now also running. All the pumps are now running. Before you continue, you observe a message on the engine warning display. The message "Refueling" indicates that the refuel control panel door is open. A few minutes later, you observe that the refueling message on the engine warning display has disappeared, indicating that refueling is complete and the refueling control panel door is closed. Now, let's continue the pre-flight by inserting the fuel weight in the MCDU. We have typed the fuel weight in the scratch pad for you. Note: you can insert the fuel weight in the MCDU even if the refueling is in progress. The typed fuel weight can now be inserted in the MCDU by pressing the line select key to right. Then, you have to check that the estimated data, the trip fuel, the route reserve fuel, the alternate fuel, the final fuel, the minimum destination fuel on board, the extra fuel, the takeoff weight and the landing weight correspond to the data on your computerized flight plan. Note: The minimum fuel quantity for takeoff is 1,500 kilo. Then, you have to check that the entered data correspond to the data from the loading trim sheet. For that, compare the zero fuel weight (CG, zero fuel weight) with the previously entered data and adjust, if necessary. Also verify the fuel distribution in the different tanks. It is now time to start the APU. Before starting it, notice that the APU triangle is white. It is to indicate that the APU valve is closed. We have started the APU. On the eCam fuel page, you can see that the triangle is now green and linked to the left-hand circuit. The APU valve is open and the APU is running. Also, as the center tank pumps are running, the left center tank pump feeds the APU fuel line.
The items related to the fuel system during cockpit preparation have all been seen. We will now discuss items related to the fuel system that you will encounter during engine start. The indications and starting procedures are the same for both engines. In our example, we will start engine 2 first.
Before we start the engine, observe the following. The engine LP valves are cross-line amber to indicate closure. The fuel used quantities remain from the previous flight. Engine identification numbers are amber. This is because the engines are not running. The optional fuel flow 1+2 indicates amber crosses. Engine 2 is starting. Observe. The low pressure valve is in line green. The fuel used indication automatically resets to 0. The fuel flow starts. The engine identification number 2 changes to white. The gross weight has now appeared. Engine 1 is starting. Observe. The low pressure valve is in line green. The fuel used indication automatically resets to 0. The engine identification number 1 changes to white. The message, "Center tank feeding," has appeared on the engine warning display. This indicates that the center tank pumps are feeding the engines. Note, as the inner tank pumps have a sequence valve, the center tank pumps, when they are also running, deliver fuel preferentially, as long as slats are retracted. The center tank pumps automatically stop at slats extension. Then, it is time to stop the APU, if it is not required during taxi and takeoff. We will now discuss items related to the fuel system that you will encounter during normal climb, cruise, and descent. You are in climb. The slats are now retracted. The center tank feeding message reappears, indicating that the center tank pumps are now feeding the engines. Note, the center tank must be emptied first. You are now in cruise. Notice the center tank feeding message has again disappeared, indicating that the center tank pumps have stopped. However, the center tank is not empty, and another automatic function has occurred. To explain why, we must look at the IDG cooling fuel recirculation system. Some of the fuel supplied to each engine is used to cool the oil system of the integrated drive generator, IDG, then returns to the related outer tank. If the outer tank is already full, it overflows to the related inner tank. When the inner tank reaches the high level, the related center tank pump is automatically stopped. So, the engine is fed by the inner tank until it consumes 500 kilograms, and so on. Then, 5 minutes after the center tank has been emptied, The center tank pumps are automatically stopped. You are in descent. To better illustrate the remaining indications, we will keep the ECAM fuel page displayed. Let's see what happens when the inner tanks reach a low level. When either inner tank reaches a low level limit, the transfer valves on both sides simultaneously open, enabling the transfer of fuel from the outer to the inner tanks. When at least one transfer valve is open, the message "outer tank fuel transferred" is displayed on the engine warning display. As you can see, the fuel is transferring until the outer tanks become empty. Note, when the outer tank is empty, the related fuel tank temperature is not displayed. The items related to the fuel system during climb, cruise, and descent have all been seen. We will now discuss items related to the fuel system that you will encounter post-flight. The APU has been started, and after engines shut down, the fuel pumps must be switched off.
Observe the transfer valves remain open. They will be automatically closed during the next refueling operation.